Hi, fifth graders. Today we are going to keep talking about classifying two-dimensional shapes or figures. Our WALT today is to classify two-dimensional shapes by their attributes. An attribute is a characteristic or something that you can say about something else. We're going to begin by reading this word problem just to get our brains thinking, and we will solve it together a little bit later. Sort these shapes into the Venn diagram below to show the relationships among parallelograms, squares, rectangles, rhombuses, and quadrilaterals. Use at least one shape in each region of the diagram. Classify the shapes by labeling each region with the category name. Before we move on, I want to just have a conversation about the fact that if a shape fits here for whatever reason, because of its attributes, its characteristics, it also fits in this whole category, so everything inside here and here. It also has the same characteristics as these shapes and also has the same characteristics as these shapes. Okay, so the shapes that are in here don't fit in the other ones. So how can a shape have can fit in two places? Well, if I were to sort, let me just make my little Venn diagram here. If I were to sort all the things that are red and all the things that are, squares, and I have a square, and I have, and then in the middle here, I had red squares, right? So, hold on. Yep, there we go. There's my square. And then I had, so my red star fits here, only there. My green square, oh boy, let me do that, fits there. But this square fits in both places. It has both attributes. The one we're doing right here just has a lot more going on. All right, so before we go on, we're going to use this attribute chart to remind ourselves about the attributes of our shapes. So an attribute is something a thing has. We also could call that a characteristic or a property. They're up here, right? The characteristics, the properties that we're looking for are at the top, and we're going to be putting a check mark in each spot. This will help organize our thinking. You may have done this in other classes as well. So here's our picture of a parallelogram. Does it have only one set of parallel sides? That word only is very important. So our parallelogram has two sets of parallel sides. It has right angles. Nope, it has no right angles. The opposite sides are equal, and it has four equal sides. Oh, no, it does not have four equal sides. Excuse me. It doesn't. So we're not going to check that off. Our rectangle, again, our first question is, does it have only one set of parallel lines? Nope. It has two sets. It has four right angles, and its opposite sides are equal. We cannot say that all four sides are equal, though. Here's our square. We know it does not have only one set of parallel sides. It has two sets of parallel sides. It has four right angles. Opposite sides are equal, and four equal sides. So you can start to think, as we're thinking about that problem we just looked at with the Venn diagrams, look at all the boxes that a square checks in this attribute chart, all the things it can be, just like that red square in our previous problem. A rhombus is next. It has two sets of parallel sides, no right angles. Its opposite sides are equal, and it has all four equal sides. And our last one is a trapezoid. And the trapezoid is going to be interesting because it only fits that one characteristic, that one attribute. It has only one set of parallel lines. So let's look at the table. Which properties are not shared by rectangles and rhombuses? So if we look at the rectangle right here and our rhombus right here, we can see that a rectangle does not have 4 equal sides, but a rhombus does. But the rhombus does not have the 4 right angles. So those, if we look at just those check marks, they check different boxes. They have different attributes. We can't see that. Which categories share all the properties listed for parallelogram? So where, what does a parallelogram have? It has 2 sets of parallel lines and its opposite sides are equal. So we're back to this previous picture. And so if we look at this, we have the quadrilaterals were put into this one here. Quadrilaterals have 4 sides and 4 angles, and they're a polygon. They're a closed shape. So they fit only there. Parallelograms fit right here because they have 4 sides and 4 angles, just like a quadrilateral, so they can go in one, but that's all they have. So let's think about where we should put the rest of them. So we've got this, we've got 2 rectangles. One's kind of a long one and one's a tall one. And so if I think about a rectangle, if I put rectangles are parallelograms, but they're even more, they've got more going on because, right, a parallelogram also has those right angles. So if everything that has a right angle we put in this one right here. So this is C and F, okay? Those have right angles, right? So does this rhombus have a right angle? We talked about that in the last slide. It doesn't have a right angle, so it can't go in this circle here. It has to go in this circle. So then the only thing we have left is D, and D is a square. Squares are special because they check all the boxes. And so D goes in the middle here because it has right angles like our rectangles, and it has equal sides like our rhombus. So we have to think about, how does this Venn diagram support the statement that all parallelograms are quadrilaterals, but not all quadrilaterals are parallelograms? So think about this Venn diagram. All of these quadrilaterals, everything in this box fits a quadrilateral. But are these guys quadrilateral? Excuse me, are these guys, they're quadrilaterals. Are they parallelograms? Do they have 2 sets of parallel sides? They don't, and we see that that's why they don't fit. They can't go down any further. They're stuck. Why is D inside all the ovals? Well, we talked a little bit about that already. It checks all these boxes, doesn't it? Mathematicians often have usually they have the same definition, but trapezoids are one of those interesting shapes where people think of them differently. So mathematicians can define them in 2 different ways. Some mathematicians say that a trapezoid is a quadrilateral with exactly 1 pair of parallel sides. Only 1. Some say that trapezoids are quadrilaterals with at least 1 pair of parallel sides, which leaves you to think that a trapezoid it leads you to think that when I use the word at least, that I can always have more parallel sides. So the difference here is how you might categorize them. So which one of these kind of thinks about trapezoids as exactly the only thing that has 1 set of parallel sides is a trapezoid? That's it. And which one has trapezoids with at least 1 pair, meaning that if it has more than 1 set of parallel sides, it still could be thought of as a trapezoid. Just like I still can think of a square as a rectangle because it has 4 sides, 4 angles, 4 right angles, and its opposite sides are equal. So which one would go where? Now in this one, I can be a trapezoid, but then if I'm a parallelogram, I could also be a trapezoid because I have at least one set, but I have more. I have 2 sets. So which one of these which one of these ideas has the mathematicians that think exactly one pair? So if I had exactly one pair, sorry, that was my eraser. If I had exactly one pair, the only place that trapezoid would fit would be by itself, because it's one pair only, no more, no less, one. So this one thinks, oh, I have at least some. That means other shapes with more can fit in my definition. But in this one, only trapezoids will be the ones with exactly one set of parallel sides. Okay, so we're going to sort these into the Venn diagram based on the properties of having 2 parallel sides and having perpendicular sides. Parallel, remember, means that they go straight up and down. These lines never intersect. They never cross. Perpendicular, the lines do cross, and they cross, importantly, at a right angle. I always think about perpendicular when I think about a street, and how a street, when I'm at a traffic light, if there are 4 corners on that street, usually those are right angles. So what I want you to do is we're going to label this this circle is going to be all the things with parallel lines, and this one's going to be all the shapes that have perpendicular lines. I want you to pause right now, and I want you to quickly draw a Venn diagram and then go ahead and sort these. I didn't really do that right. Okay, so now we're back. And I want you to, let's go over this together. So we're going to sort them based on their sides. So the first thing you should have asked yourself when you were doing this on your own was, okay, if it has a parallel lines, I'm going to put it over here. If it has a perpendicular lines, put it here. But of course, there are some that have both. So let's look at A. A has parallel lines, but it has no right angles on it. So it goes here. B has parallel lines, but it has right angles. It's a square. So where it's going to go, oops, sorry, wrong spot. Sorry. I got overexcited here. There's a B. All right, so C has no right angles, so it can't have any perpendicular sides, but it does have parallel sides. D has no parallel lines, but it does have a right angle, or perpendicular lines, because we see that right angle right there. So that's a D. E, I see no right angles, meaning we cannot have perpendicular sides. So I'm going to put E over here. And F, I have perpendicular and parallel lines here. So I'm going to put that there. So I've sorted those by their attributes. All right, so what we're going to do today is a little different, and I want to show you what that looks like. I've put the link to the worksheet that you're going to do in the calendar. So you're going to click on that calendar, but I'm going to show you what it looks like now because I want to show you something. Okay, so this is your worksheet for your work that you need to submit to your teacher. All of these boxes are little places you can put in work. You can actually type into it. So this is the tree diagram that you have been using with earlier in the week with Miss Butler and Miss Carnero. So I'm gonna start us off, and we're gonna think, what of these choices right up here, what of those choices could I have put at the top? That's all the two-dimensional shapes in here would fit into this polygon. If this says polygons, all polygons fit here. All right, and so I'm just going to cross off polygons. Now, I also think where else could I go here? So I've got triangles, hexagons, squares, rectangles, quadrilaterals, and there is actually a typo on here. This should say equilateral triangles in one box. It's not 2 boxes. Okay, equilateral triangles we're talking about those specific triangles. Remember, those are boy, sorry, I went back to my equilateral triangles. Remember, all the sides are exactly the same length. Those are equilateral triangles, sorry. So if I think about the one that only fits in the polygon box, the one that fits only as a polygon is the hexagon. Okay, and so I'm going to cross that out. And so I'm going to actually have you fill in the rest and think about where they're going to go. So we've got triangles, squares, rectangles, quadrilaterals, and equilateral triangles. I'll give you one more hint. This is a quadrilateral. You have some quadrilaterals to fill in and something else, and I bet you can figure that out. So let me erase this stuff because this is all right. And the next thing you're going to do is you are going to, looking at your tree diagram, you're going to figure out all the categories that apply to each figure, meaning what of this, wherever you put rectangle, what can it be called? It can be called a polygon. It can be called what? There's a couple categories into which it fits. And then this last one is, where does the acute triangle fit? If you were to have an acute triangle. So acute triangle, remember, is that all the all the angles are acute angles. That's an acute triangle. So be thinking about what I just drew when I drew your equilateral triangle. Equilateral has all the sides the same. Acute triangle has all acute angles. So that makes it a little bit different. Now, this is why I wanted you to come here. You're going to click the finish button when you're done. You're going to type right in here. I can type right away, blah, blah, blah. I hit finish. Okay. And then I get to email this to my teacher. You just have to email, no pictures this week, or no pictures today. You're going to click it and you're going to write your name. And I'm Miss Linda Christ. And I'm in 10B with Miss Carnero. And this is math. And you are going to use this key code right here. This right here. Oh, sorry. V4S0. This looks like these are zeros, not O like the letter, but 0 like the number. So you're going to put this class code into this spot right here. And you're going to click send. And when you do that, it sends it to your teacher and they can look at it. And so, yeah, that is what you're going to do for this week. I'm going to go back to this. Remember, you're going in the calendar. There's going to be the link to the worksheet. Click on the link, do your worksheet, and then send it to this code, okay? All right, I hope you all are doing well. We miss you tons and tons, and I hope you enjoyed your geometry lesson today.